Okay, good evening, everybody. So we're going to do the last part of graphing quadratics and finding the different points is finding the vertex of any parabola. So these are for the ones, we use it for any of them, but we mainly use it for the ones that are not factorable and have a discriminant of 0. There is no discriminant. So what we're going to do here is we need a formula. So the formula that we're going to be using is x equals negative b over 2a. That probably sounds a little bit familiar to you right now. We've got some parts of that in our quadratic formula, and so it shouldn't be totally foreign to you. And we're just going to plug in. So it's the same a, b, and c as before. So just to clarify, it's the coefficients that are the variables. So a, b, and c, a and b are the 3, or excuse me, a is the 3, and b is the 6, and then the constant is the -7 when we're doing a, b, and c. You don't include x, or the variable. And a few people are still doing that, so I want to make sure I clarify that real quick. So, that's a right there. Okay, so I'm going to go ahead and plug in. So I have equals, and then negative, and make sure I'm using my parentheses as always. I know some people said they'd never heard me say that before. So in case I've never said use parentheses, I'm saying it right now. And 2 times 3, so then this is -6 over 6, which of course is equal to -1. So what I just found here is I found the x value. Okay, x equals -1, but I'm trying to find the vertex. So if I'm trying to find the vertex, that means I need to have a point. And so to find that point, I'm going to take my x value just like we did before and plug it back into my original equation. So I have 3 times -1 squared plus 6 times -1 minus 7 equals y. So -1 squared is 1 times 3 is 3 minus 7 equals y. And then that of course is equal to -11. So y is equal to -11 when x is equal to -1. Okay, now I think I should have enough information to graph. So on the next slide, we're going to graph this, where x is -1 and y is -3. Not -3, but -11. So x is equal to -1 and y is -11. Okay, so I'm going to go ahead and plot that. And so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I'm going to plot the point, -1, -11, so there's -1 here, and then -11 is to right here. So I'm going to add one there, and that is right there. Okay, that's one point. Then another point is going to be the y-intercept, and this is the y-intercept here. So I include the sign, so that's at -7. And then my last point is reflective over the vertex, and so here is my vertex line. And so it's going to be 1 on the opposite side, and then at the same level as 7. So there's my line, excuse me, my points. So then my equation is going to go like this. Something like that. And pause. So you can see that we use it a lot of times when we are not going to cross the x-axis, but we can. We can still have graphs that cross the x-axis. The main thing I want you to understand here is that when we want to find the vertex, we can use the equation x equals -b over 2a. And then we take that and we plug it in to find the vertex. Okay, let's take a look at the next one for me, please. And here we have this one. So we're going to do the same thing we did before. We're going to use the same formula, which is x equals -b over 2a. And then I'm going to use my same a, b, and c. And of course here we're going to have A is equal to, excuse me, B is equal to, whoops, let me change that. B is equal to -8, and 2 times -5. So up here I get +8 over -10, which is equal to -0.8. And now I need to find my y-intercept, or my y value of the vertex. So I have -5 times -0.8 squared minus 8 times 0.8 minus 1 is equal to y. So here I have -5 times, and -8 squared is positive 0.64 minus, actually plus, oh no it's not, sorry. It is, yeah, plus, should be a negative inside there, plus 0.64 minus 1. Excuse me, not 64, boy, 6.4. Man, getting all confused here. Try that again. Plus 6.4. Alright, there we go. Put those decimals in a little bit easier to see for you guys. Okay. Alright, so now I have -5 times 6.4, which is going to give me -3.2 plus 6.4 minus 1. So -3.2 times 6.4 gives me 3.2 minus 1, which gives me 2.2. Okay, so that's going to be my y value, is 2.2. So I now have -0.8 for the x and 2.2 for the y. Now I can plug those in over here. -8 and 2.2. So for this one, I'm going to make my graph a little bit bigger than I did on the first one using different scaling. So I'm going to go 1, 2, 3, 4, 1. And 1, 2, 3, 4, 1. And 1, 2, 3, 4, -1. This is something I don't think you guys are doing a very good job of when you're graphing. You're just keeping like each box is worth 1 and your graphs are really tiny. You don't have to do that. You'll see with this one, actually, it's not going to work exactly. I should make this a 2 right here. 2, whoops. And then this down here would also be a 2. -2, I should say. There. Okay. So I need to plot this. So I'm going to plot my vertex, which is -0.8. So here is 0.25, 0.5, 0.75. So -0.8 is right about here. And then 2.2. So that looks like it would be about right there, is for one of them. That's my vertex. So my vertex, or my line of symmetry, is going right through like this. Okay, there's my line of symmetry. And then I'm going to plot my y-intercept, which is right here at -1. Just like that. So then I need to go over 1, 2, 3, and then a little bit more. So I'm going to go over 1, 2, 3, and a little bit more. So it'd be about right here. So then my parabola looks something like that. And again, this parabola crossed the x-axis, but it doesn't have to. The main thing we're working on here is finding that vertex, and then you just use the other 2 points. So we can use 3-point method for this one. So sometimes we use 5, sometimes we use 3. In this case, it's a 3. Okay, that's the notes for tonight, and I will see you guys tomorrow.